This is Befunge, a two-dimensional stack-based esoteric programming language invented in 1993 by Chris Pressey. Now, if you didn't understand anything I just said, don't worry about it because I'm going to explain it all in due course. First of all, esoteric programming language. According to the wiki, an esoteric programming language, or esolang, is a computer programming language designed to experiment with weird ideas, to be hard to program in, or as a joke rather than for practical use. So essentially, it's a programming language that people have made just to explore interesting ideas. Befunge's interesting idea was its two-dimensionality, which means that whereas most code runs line by line, essentially one-dimensionally, Befunge runs in a grid, specifically an 80 by 25 grid. It starts at the top left, and it follows instructions that you give and does different operations. So for example, this is printing out the words, "Hello, I am Befunge." You can see here these arrows, which tell the computer which direction the program is going in. So for example, here it starts going left, goes along here, and then it goes down, and so on. The way this would work in Minecraft is you have your blocks in a two-dimensional plane, and then you can write your computer program out of Minecraft blocks. And that's exactly what we're going to be trying to make today. Let's get right into it. Also, in the description, I'll leave you a link to the esoteric programming language wiki page on Befunge, so you can have a look at the inner workings of Befunge, or also some more esolangs. This is the list of all of the commands that you can do from the original version released in '93, and so we're going to aim to add all of these in Minecraft. I'm not sure if it's going to be possible, but well, we're going to try. So the first things we'll need to add is these directional arrows, which allow you to change the direction that the program's running in. So I thought the perfect thing for that is the magenta glazed terracotta, which literally has an arrow on it. So, you know, you have the 4 different ways, and then you can tell which ones are which because you can see here it is facing south, and then this one is facing west, and then you can decide based on those things. Although it is kind of weird because we're facing north, but this is facing south, so I don't really know why that is, but anyway. So then you, for example, have your program, so you go like that, and then maybe, like that, and then, you know, you can turn your program in whatever different directions, and then it will end with a bedrock, and let's just say it starts with stone for now. So bedrock means that it ends, and stone means that it starts. So let's just start adding this functionality. I'm going to do this in command blocks first, because then it will just be easier to check that it's working properly before we actually migrate it to a datapack. Okay, so we got our armor stand, which is going to traverse the thing, and basically it's going to, every tick, it's going to teleport in a certain direction, and then it will check what the block is and execute some function based on that block. So let's say that it always starts going west. No, let's say that it always starts going north, because that's how the armor stand starts facing. So let's just put this here, except we don't need that. We could have, let's say it goes like that, and then like that, and then like that, and then, you know, that will end on the bedrock. So let's add this functionality. So what we need to do is we execute as all the armor stands, the tag that I gave it, and we're going to just teleport 1 block forward. And that means that what we can do is we just change the way that this armor stand is facing, and then it will always go in the correct direction. Then we need to do the check. So we need to execute if the block, except as all those entities. If the block is magenta glazed terracotta facing, if it's facing south, then we need to set the rotation to be minus 180 and then 0. If it's facing south, then we're going to teleport it to there, followed by minus 180 and then 0. So now if we copy this and then just paste it a couple more times and change this. Okay, and then the last one we need to do is if the block is bedrock, then it will just kill itself. So now hopefully, if we turn this thing on, nope, okay, it's facing the wrong way. Let's see if that works. Okay, perfect. you can see there that it killed itself, you know, teleported, and then run that again. It goes through the path and does everything properly. So that is the movement working. And then let's just make any random block, let's just say a grass block for now, is our debug message. And every time it hits a grass block, it will just say hit a grass block or something like that. Just get another one of these. So that will be useful for debugging when we want to make sure that the arm stand goes through this particular path. So now if we run that again, it says I hit a grass block twice. If we say break one of these, then it should only say it once. Perfect. Now we should probably migrate it to a datapack, because otherwise we're just going to start having tons of command blocks and it's going to get unwieldy. So now if I turn this off and press that again, it's not moving for some reason. Why is it not moving? I don't know. So it is ticking. So why isn't it teleporting to one in front of it? That's the question. Oh, I think I know why it's not working. I think it's because it just needs to execute at s, run the function, because that way it actually updates its position. Otherwise it thinks it's in the same place before it was teleported. So now if we reload, it's gone, but it didn't. Oh, that's because we didn't add the grass block check. And then it says I hit a grass block. Now we can get to work on some of the functionality of the actual language. So, as I said earlier, Befunge is a stack-based language. You might see here, if you were reading the documentation, that it says a lot about stacks and popping and pushing. This is essentially what a stack is. Think of a stack like a stack of books or a stack of blocks. Let's say that each block has a value, so maybe polished andesite is 1, acacia planks is 2, and deep slate coal ore is 3. So when you push something onto a stack, you put something on top of it. So the acacia planks we said was worth 2, so that is like pushing the value 2 onto the stack. Then let's say we push the value 1 onto the stack. Then we have a add operation, which in the documentation says that it pops two values, a and b, and then pushes the result of a plus b. What popping from the stack means is taking off the top. So it will take off 1 from the top of the stack, and it will take off 2 from the top of the stack. It will add them together, which is 3, and then push that back onto the stack. And that is how a stack works. You can push values onto the top of the stack and pop values off of the top of the stack. Now in Minecraft datapacks we can use an array or list, which is basically 2 square brackets, which is just a list of items. So maybe we have 1 and then we have 2, and then it goes through this add operation and then it becomes just a 3. Okay, so I've implemented the add operation. I haven't tested it yet, but essentially what it does is it runs the pop function, and the pop function will take the first item in the stack from the storage and set it onto the current property of the storage, and then it just removes whatever's in the first bit of this stack. Then it stores that onto a score, then it pops another value and stores that onto a second score, then it adds the 2 scores together and stores that onto the arguments storage, which is basically the arguments that are passed to the next function that is run. It runs the push function, which takes 1 argument, which is this, and that will just add onto the beginning of the stack from the first argument. So all we need to do is manually modify the storage, and let's just set it to, for example, stack, and we need to prepend value 3, and then we'll also prepend the value 6, and then we run the function. It got a and b, and now if we do data get storage main, the stack is empty. Why is the stack empty? Because args 0 wasn't anything before. Maybe we have args be initialized with just 0. And then if we reload and we modify the storage again, then we run the function add, the stack has a single 9 on it, which is perfect because it added 3 and 6, which is exactly what we wanted. So the add operation is working. So now we just need to implement this into the check block function. Question is, what block will actually represent the addition? I'm not sure. Copper might be good because it kind of looks like there's a plus. So let's say oxidize cut copper, but that's not enough because how are we actually going to get values onto the stack? Well, first of all, let's just check that this works. So we'll reload. Let's just add the values onto the storage, and then we run the function. If we do this data get storage, the stack has 9 on it. I think we should probably add something that lets you push values onto the stack. So in Befunge, you can use the numbers 0 to 9 to push the corresponding value onto the stack. So if you have, for example, a 0, then it will push a 0 onto the stack. If you have a 3, it will push a 3 onto the stack, etc. What is the best blocks to push different numbers to the stack? Probably something that has some kind of variations. For example, wool might be nice, or concrete, because that way we can have different variations mean different colors. I don't think there's really anything that has intrinsic numbers on it, apart from something like a sign where you can actually modify the MBT data. You could also do maybe a chest and have the count of the first item in it, define it. That is actually probably the best idea. So you have a chest, and then the value is determined by the number of items in the first slot of the chest, or it doesn't really matter, it's just the first one when you're going along like that. That won't work because items in Minecraft can actually go up to 64, whereas you're only allowed to go up to 9 in Befunge. So what I'll do is I'll do modulo 10, which basically divides by 10 and gets the remainder, so that will mean that it's a number between 0 and 9, which is exactly what we want. It also means that to get 0, you'll actually need 10 items in there instead of 0. Let's just add a 6 onto the stack, and then hopefully this will add a 3 onto the stack and everything should work the same as before. It has a 9 in it, so that works. And if we, for example, run this again, it should add the 3 onto the stack and add it to the 9 that's still on there, and we should get 12. We got exactly 12. Pushing values onto the stack is working. Now I'm going to make subtraction, division, multiplication, and also modulo. Okay, so those are added, and now if we replace this with a jukebox, I decided a jukebox because that kind of looks like a minus sign, then hopefully it should subtract 3 and we'll get 9. No, we got 9, but it didn't push the value onto the stack. Oh, so that seemed to work. I don't know why. Okay, I'm not exactly sure why it was, but I managed to fix it. I just made it so that if it doesn't have anything on the stack, it will just automatically push a 0 when it pops something, so that means that you'll never have errors of like weird values and stuff. So for divide, I had light blue glazed terracotta. For multiplication, I had a honeycomb block, and now we should have -9. Perfect. For modulo, I had nether quartz because I knew I wouldn't be able to find anything that looked like a percentage sign, so I just went with nether quartz for no really good reason. -9 modulo 3 should be 0, hopefully. Yes. Okay, so all of our mathematical operations are working properly. We have our logical not operator, which all it does is pops a value. If it's 0, push a 1, otherwise push a 0. So I'm going to make it bamboo. So now what I can do is we're going to push a 3 onto the stack, and then we're going to, what we should see is that hopefully on the stack should be a 0. Break that block. On the stack is a 0, so hopefully now it should be a 1, and it is a 1. This is actually turning out to be quite a lot easier than I expected, but we'll see when it gets to the more complicated operations. So next we have our greater than. It pops A and then B, and then push a 1 if B is greater than A. otherwise it's a 0. So the way it works is that first A gets popped, so it means the most recent one that was added needs to be less. If, let's say, 2 is less than 3, so we should get a 1. 2 and 4. Why is it still got 2 and 4? Why hasn't it popped them? Oh, because we don't have anything that checks if they're greater than. Okay, we will make it a soul torch then. And then it's got a 0 because it pops A and then B, because it then sets B to be 1, and then 1 is not greater than 2, so then we're just going to have a C score, and then it will just put it onto that instead. And now it has a 1, and if we make this more than that, so this is not greater than that, so what the 1 was from before, and then the 0 is the newly pushed 0, that means that it's not greater. Then we have our arrows, which is fine. Okay, so random direction. Okay, so this should be a little bit more interesting because there are several different ways to get random numbers. What I think I'm going to use is I'm going to use spread players. So it will spread all the armor stands with the tag of spread around this point with the minimum distance between them of 0, because it's only 1, and then up to 1 block away. So if we do this, then it will hopefully go in a random direction, which is one of 9 random squares. It can be one of these 9 squares. So then what we can do is we can get path armor stand to face this new armor stand that's been spread in a random place. That will be the new direction. But there's a couple of problems. We don't want it to be facing diagonally because it needs to be in one of 4 directions. We also don't want it to be in this specific block. Probably check if the entity less than 1 block away. Then we just run this function again. We can wait until it goes into one of these positions, then we run the same position there, position there, position there, and position there, and we keep on spreading it until it's in one of these 4 directions, and then we can teleport facing to it. Then what we should do is we have chests in different directions and then bedrock at the end. If it goes into this direction, it will just go back into the dropper, and if it goes into any of these, it will put either 1, 2, or 3. So now, okay then. So it did seem to go in a random direction because first it went there and then it went there. But I think I know why it's doing that. Spread players actually goes onto the highest block in that coordinate. So it will, for example, go to here if it can. So what we need to do in random direction, instead of going tilde tilde, we just go tilde 0 because that means it will always be facing straight. So now if we try again, we get storage, it has a 1 in it, so that means it went in this direction. Now it has a 3 in it. Let's just run this a few more times just to be absolutely sure. Perfect, it has all 3 different ones. It doesn't seem to have 3 as much as 2 and 1, but that's just randomness. Now we have our control flow. We have 2 if statements. We have horizontal if and vertical if, which are basically pop the value, if it's 0, go in a certain direction. So for our horizontal if it's 0, then it will go north. If it's anything else, it will go south. And for our vertical if, it will set it to east if it's 0, and west if it's anything else. Let's have it be a comparator. Actually, a comparator would be kind of good because a comparator like compares 2 redstone signals. Maybe I'll change it to that instead then. A repeater can be the if statement, so faces whichever direction is when it is 0. It will just be these 2 directions. So it's very simple. It just pops a value, stores that into the A score, checks if it matches 0. If it does, it teleports to be facing north. If it doesn't, teleports to be facing south. Now the vertical if is almost identical. It will just set it to -90 if it's 0 and to 90 if it's not. We'll add 1 to the stack repeater. It should shouldn't go this way because it's not 0, so it should go this way. Then it will add 3 to the stack. If it goes this way, it will add a 2 to the stack. It has a 3 on the stack, so it went this way, which is correct. Okay, so the next is toggle string mode. Now, I'm actually going to skip this for now because strings and all of this stuff here is basically the more complex parts, which we'll probably cover after. I just want to get finished the basic functionality, and then we can have a look at inputs and actual outputs. So these three are pretty straightforward: duplicate top stack value, swap top stack value, and pop top of stack and discard. Those are all pretty straightforward, so I'll just code them in. If we have a chest, puts 2, and then we get a cauldron and then lava, that should pop the top value off the stack and discard it. So now if we run this, it has nothing in it. And then we have our swapper, so push the 2, then we push a 3, so it should be 3 then a 2. Verify that quickly. But then if we do our swapper, which is a piston, then it is a 2 then a 3 because the top values get swapped. And if we add a dispenser, that should duplicate the top stack value, so now we have 2 2s instead of just the 1. The last thing we can add before we need to do some of the more complicated stuff is the bridge, which literally just lets you jump over the next character or block. If you have a bridge, which I'm thinking of having as some kind of stairs, let's just have it be cobblestone stairs. For example, we have our piston. This actually won't trigger because the stairs makes you jump over. That's really simple. All we need to do is teleport them 1 block forward, and that will take care of it. This output should be the same because it just skipped over them. Yes. So we've done the basic stack modifications, addition, subtraction, if statements, etc. What we have left is the strings, ASCII, inputs and outputs, and stuff like that. I think that's going to take quite a long time, so I'm actually going to split this video up into 2 parts, because I've already been recording for about an hour and a half, and the video will probably end up being quite long. So if you enjoyed this video, then I'll leave a link to the next video in the description and on screen now, if you want to watch that when it comes out, obviously. And I'll leave a link to the pack in the description also when that's done, so you can go and check it out and make some Befunge programs in Minecraft.